Okay, so we are doing 1C point 13 through 14. I just combined them together. Most teachers are combining them together because they tend to overlap in topic. Basically, we are creating a model, aka a regression, to represent a data given to us. This is a major part of AP Pre-Cal and was a major part also in Pre-AP Algebra 2. Okay, these topics will utilize graphing calculators heavily, and that's just the main thing. You have to have a calculator and be comfortable with it. Okay. The main polynomial functions that we're working with are linear, quadratic, cubic, and quartic. And then for rational functions, building from there. When you're building your regression, remember we're entering our data into the calculator, correct? So remember stat edit. So we're gonna go to stat, go to edit, and we input our values into L1 and L2. Yes? Everyone remembers that? Sounds good? Sounds familiar? After you go to stat edit, you then are going to go stat menu and you're going to arrow over to calc because we want to calculate. All right, depending on what we're trying to calculate. All right, there are two linear regressions. We're going to be using the first one, which is linreg ax plus b. And then the second one is pretty much the same. It's just using AP stat instead of AP pre-cal. Okay, so it's still the same. After that, it's going to tell us, okay, here's your data. Where are you going to store it at, or what data am I pulling from? If you put your X values in L1, you want to make sure it says L1. If you put your Y values in L2, you want to make sure it says L2. And then a tip is store, store, store. Okay. Storing is important because when you store it, it creates the equation for you in Y1 and it automatically graphs for you under your graph, right? So we would store it. To go down store, you come here. And remember, after the update, the fancy calculators, you just have to press alpha and then trace to select Y1. Okay, so are we ready to run through a review of a regression model? Linear regression. Yes? All right, so I'm going to pull out homegirl Sylvie, wake her up. Yes, but I'm not going to go through the steps with that. Huh? I mean, that's what they said. So, all right, so here we go. We have stat. We're going to go to edit. If you're using your calculator and it hasn't been reset, remember second plus 7, 1, 2. You want a fresh face calculator when inputting. Okay, so we have stat, edit. Going to put in the values. I have 4, 5, 6, 8, 12. Then I have 4 and 2/10, 4 and 4/10, 4 and 8/10, 5 and 1/10, and 5 and 7/10. Okay, so the given data here represents the age in weeks and weight in kilograms of 5 randomly selected babies from a particular pediatrician office are listed in the table above. And we want to create a linear regression. Y equals A plus BX can be used to model this data where Y is the predicted weight of baby in kilograms that is X weeks old. Okay. Again, it doesn't matter if you use A plus BX or AX plus B because it's going to be the same. They both represent a linear. All right, so now I put my data in. I'm going to go to stat, calc, and I just choose 4 because it's right there. If you would like to do the one in the notes, it's 8, and then we're just modeling it to show you that it's the same either way. So I'm going to press 8. L1 is my X values. L2 is my Y values, so that is good to go. Now I need to store on your calculator. You're going to press alpha trace, and it should say Y1, and it's going to store it. You can use bars. Yep. Yeah. Out of 2. But the calculator's been updated. So you can just hit alpha trace and it goes right to it. Or old school way is always good. Bars, Y, 1, 1. Still going to get you there, right? Either way. Okay. Then you're going to calculate. It's going to calculate your model. Okay. Notice that when I calculate it, it did not tell me my R squared or my R value. If I am looking for that or need that value, does anyone remember what you need to do? If I want the R squared value, does anyone remember what we need to do to get that R squared value? Something has to be turned on. Okay. They no longer keep it on. Why? Because they're weird. But you have to go to mode and you have to go to stat diagnostics, and your stat diagnostics has to be on if you're trying to see if what you're creating is a good model. Okay. That's our site. That's turning on your stat diagnostics. And so now I'm going to rerun it. I'm going to do stat calc. I'll press 8 so that it follows your notes. I'm going to make sure I store it. Alpha trace 1. And now I'm going to calculate. And notice now when I calculate, it's going to tell me the R square and the R value. Yes. What if I do that in Desmos? I'm not doing that right now. So, yep. Okay. The other thing is that if you have had, like struggles with writing your linear model or not sure how to write it or what to write it, there are ways that you can do that. So for a linear regression model, I'm like, oh man, I'm not sure what's my 3, what's my 4, where things are going in. Because you stored it, it automatically writes it where it goes. So you can go to Y1 and it'll tell you what your Y equals. So it'll literally tell you, oh, here's your Y. My Y equals 3 and 545 thousandths plus 185 thousandths times X. It'll automatically write it in the form for you. Okay. Which is a big difference from Desmos because Desmos will not ever automatically write it for you. Okay. The beauty about storing and factoring this now is that you can just literally solve values from your calculator mode page. So if it asks me, what is the predicted weight in kilograms of a baby that is 10 weeks old? Could I go look at my table? Yes, I could. I could go look at my table, but I also can just go to my calculator page and I'm going to hit alpha trace 1 and I can type in what is y of 10, f, which is the same essentially as me writing f of 10, f of x, well, f10 instead of y, but I can literally just type it in. It's going to tell me this is the baby's weight. Using the equation in y1, this is your baby's weight. Does that make sense?
That's so cool.
Yeah. Isn't that nifty? Okay. If I need to know what would the baby's weight be based on this model after 20 weeks, I would do the same thing, except I would just go up, arrow up, hit enter, and change 10 to whatever I needed to be. So if I need 10 to be 20, I'm going to type in 20, and then there's the baby's predicted weight after 20 weeks. Cool? All right. The next part is using this. It says, what is the weight of a six baby is 5.3 kilograms. That's a weird way of wording that. A 6-week-old baby, I think is what it's saying. Okay, I didn't write the word problem. I'm gonna lie to y'all. That is really worded really. So it's 4.8 age in weeks of this baby. Okay, we're just gonna focus on the part. We're gonna erase this part. I think that's a typo. What is the weight of a baby?
I think
Is 5.3. Yeah. Huh? Yeah. I think it just wants to know if the baby weighs 5.3 kilograms, what is its age? How many weeks old is it? So your weight is your watt, yes.
I think that's the weight, but how do you insert one?
Alpha trace. This is weird. So we're just gonna say the weight is 5.3 kilograms. Using the model from part A, what is the age in weeks of the baby? There's a lot of excess there. So in this case, it's telling your Y. Your Y equals 5.3 kilograms, right? And it wants to know what is the baby's age. The thing that we're going to do here is we're going to graph this, and this is going to be our Y2. So this is going to be our Y2, and we're going to then look for our intersection. Okay? If you're using all calculator, that is what you're going to do. However, if you didn't want to use calculator, could you set your equation equal and solve for X? Yes. But we're practicing using our calculator. So we're going to go to Y equals, and this time we're going to add in our Y2. Our goal is 5.2. We want to know how old is the baby if its weight is 5.2. 3, yep. I'm going to hit graph. So there's my initial linear equation. And then it's going to graph my 5 3/10. And I want to know where they intersect because that's what's going to tell me my X value, right? So I'm going to hit second, trace, and you see where it says intersect. Press 5, enter, enter, enter. And they are approximately when X equals 9 4/9 weeks old. I got 9 49. All right. How do we feel about using the calculator's resources appropriately to our abilities to help us solve? Okay. Did this feel like a review? I hope good, because it should not have felt like never done this in my life. Okay. Then I'll be mad. All right. The next part is knowing which model to use. Okay. So while some problems will indicate, hey, this is going to be a linear or quadratic or whatever, however, some do not. And you have to decide which one am I using. Okay. Key things for linear is if it's a constant rate of change, right? It's increasing miles per hour, something per is a good sign that it is linear. Okay. Quadratic, roughly changes in a linear rates of change or are roughly symmetric with a single minimum point. Like here's my maximum, here's my minimum value. And then also cubic, context involving volume. Anytime we're talking about volume, you want to think, oh, that's a cubic model. Okay. The other thing is plot the points and analyze the plotted points, right? Plotting the points and analyzing what shape is it making. Is it making a parabolic shape? Is it making a linear? Is it a cubic? Am I increasing, then decreasing, then increasing again? So what type of model is coming into play? Okay. So for example here, it says for each of the following situations, determine whether a linear, quadratic, or cubic model would be most appropriate. Okay. So I'm going to pause for a second. And I want you to go through and decide on these three, which would be the best model, linear, quadratic, or cubic within your group. And then we're going to come back and check. All right. So on 2A, what did we decide? Why is it cubic? Volume. If I'm filling something up with water, that is referring to volume. And the key word is volume. All right. B, what are we doing? Linear. Why is it linear? All right. Why is it linear? Why is it linear? Anyone? It depends, right? And there's a price per topping, right?
It's a variety. It's a variety.
Yeah, but you're paying depending on the variety, right? Remember I told you that the word problems are not going to be as straightforward as they were in pre-AP Algebra 2? I warned you all that they weren't. So tricky. It's going to be a price per topping. How much my pizza costs is going to depend on my toppings. I know, it's crazy. Tried to warn y'all. Depending on some toppings may cost a certain more than others. Like meat topics, we have more than 2 minutes. We're still on hold. silly. Oh, I heard. Nope, I wasn't. Because I was trying to teach my class. Duh. All right, last one. It should be quadratic. Why is it quadratic? Area.
You're stupid.
Okay, we're all intelligent. No need to insult one another. We are all intelligent. We're all intelligent. They love each other if you're listening to this video. Thank you very much. All right, so how do we feel? Okay. All right. The only other thing that we would have to review, I was gonna have you guys do this one and then determine whether it was linear, quadratic, or cubic based on the pairs and looking at the scatter plots. And then we were going to talk about residuals. You guys remember finding the residuals? Okay, residuals, remember, is your actual value minus your predicted. We're going to rap about it. Residuals. I'm going to rap. Okay, residuals equals actual minus predicted. Okay, so really quick, the plan for next week.
I saw it in